Hey guys, what's up? This is our project Connects Pulley by Sharuq and Felicia Adams.
This is our project description. So our goal was using Connects to build Pulley's models and determine how mechanical advantage is applied in each system. Using what we learned to build the Pulley machine, we built an elevator, as you can see here and here.
Basically, our goal was to use the Connects to build a model and to understand how mechanical advantage were applied and work in the Pulley system. So as you guys see here, our project was to turn those little pieces into elevator, and that's what we did here. We turned these little pieces to something that actually people use it in real life.
So you ask, what are pulleys and how do they work? So pulleys is basically a wheel with a groove frame around which a cord passes. It acts to change the direction of a force applied to the cord and is chiefly used to raise heavy weights. Pulley systems move objects using a rope or metal cape and grooved wheels or pulleys. By wrapping a cable around one or more pulleys, the system can redirect and distribute force and change the direction of motion. The dynamics of pulleys are the branch-shaft mechanics concerned with the motion of bodies under the action of forces. So right here in this picture, you see a man pulling a rope, trying to raise this type of bar that's down here, which is load. So the pulley is like these two circles, also the rope, and it's him like using his force to pull the rope back to bring up the load. You get it?
So how do they work? Well, I'm here to tell you. So they work. There are many different types of connects, okay? So there are a lot of types of connects, which is, for example, we have lever pulleys, and we have wheels, gears, and wedge. And how do they work? So basically, pulleys system move object using a rope or a metal cable to actually they apply force or effort in order to raise the load, which you guys see here. There's a load here and a man with a rope. He actually applying force on the rope to raise that load, and you see in the picture here too. This is actually was used in real life. Back in the days, they were used to get water. And as you guys see here, these are the type of connects. These are used in real life as well.
Okay, so mechanical advantage. What is mechanical advantage? Mechanical advantage is the ratio of the force produced by a machine to the force applied to it, used in assessing the performance of a machine. So an example is 20 pounds times 5 feet equals 100 foot-pounds. This setup requires us to exert only 20 limbs of force to lift the 100-limb block the same height as before. This is mechanical advantage in action. The class 1 lever shown to my right. The class 1 lever shown above has a mechanical advantage of 5-1, since we use 1/5 as much force to accomplish the same amount of work. Many machines are designed for this purpose. Gears, levers, pulleys, and screws are just some of the devices we use to gain mechanical advantage. And how do they work? Mechanical advantage is a measure of the force application achieved by using a tool, mechanical device, or machine system. The device preserves the input power and simply trades off forces against movement to obtain a desired amplification in the output force. So if you don't understand what's going on in this picture over here, that's 50 limbs. This is the almost like the mechanical advantage, you can say. This is the applied force, basically gravity, because it's holding it down. Yeah. Okay, my mistake. This means pounds, and I said limbs, but disregard that. Anyways, yeah, the applied force is 10 pounds, so I'm guessing that's the mechanical advances that's working here. Yep.
So as Felicia was saying that in order to lift something, it have to be like you guys see here the force. I mean the as you guys see here the load, the yellow thing right here. This is 50 pounds. In order to lift the 50 pound, you will need, so you apply force 10 pound on a distance 5 feet in order to lift the 50 pounds. And that's how mechanical advantage work.
Let's get further into our project. So, now I'm going to take you through the process of building our model. So, step 1 was collecting all the pieces, which altogether we gathered 226 in total. A lot, I know. We collected 14 classic Connects clips, which were these little purple things. 12 classic connectors, which were this red one, this blue one, and a white one. 18 rods were these long thingies. 12 connectors, those were more connectors. And 3 small wheels, which we don't have a picture of it, but that is what we used to begin our process in building our model. Difficulties and solutions. So difficulties. Some of the challenges that we had building our model were putting some of the Connects pieces together because some of them were confusing on how they were placed with the other pieces. Basically, like some of the parts, like the Connects connectors, they would have like different little areas where you have to connect them, and it got confusing because I didn't know where the rods went or how it went, like, into them and how they connected with the rest of the pieces to make the project, the model. So a solution was we got help from our teacher, and we watched YouTube tutorials on the model that we were building, and we saw how other people put the pieces together, and so that helped a lot. This is our final product. So it was the elevator, and the elevator, it's 2 of them, and they are like 2 different ways. Like one has both wheels on it, one has just one wheel at the top, and the string is tied like right here. And all we did was pull the string down, this went up, and we did the same thing on that side, and that was basically an example of mechanical advantage and how an elevator works behind the scenes. So concepts that we learned were knowledge about pulleys, what they are, how they work, and how people use them in everyday life without really knowing. How pulleys is used in real life scenarios, riding a bike, lifting weights. This pulley, I think that's upper arm strength exercise. And climbing up, rock climbing, climbing up the wall, and cranes, lifting stuff up. And we learned how to build a pulley model using Connects, like little connecting pieces, which was an elevator, and that was one way of a pulley machine and a prime example. Thank you.